Now that we took a look at integer exponents, we need to start looking at rational exponents. And so by the end of this video, you'll be able to evaluate and simplify rational exponents. To preface, rational numbers are any numbers that can be expressed as a fraction of two integers, and rational exponents come in the form of b to the power of m over n, where m and n are both integers, and n is not zero since, again, to remind you, we cannot divide by zero. Now, if you watched my previous video on integer exponents, you should be familiar with integers, and so it can be noted that every integer is also a rational number, but not every rational number is an integer, since every positive or negative whole number can be written as a denominator of 1. So for example, if we had 3, 4, -2, -1, all of these can have a denominator of 1 and hold the same value. But not every fraction can be simplified to a positive or negative whole number. So for example, if we have 5 over 2, this can't be simplified down to a negative or positive whole number, therefore it can't be an integer. So what I just explained here is the fact, which is that the set of all integers are a proper subset of the set of all rational numbers. We'll start simple by looking at the special case, which is b to the power of 1 over n. So instead of b to the power of m over n, which is a general case, all we did is replace m with 1, where m is our variable. And so b to the power of 1 over n is equivalent to a to the power of n, which equals b. Or in other words, when evaluating b to the power of 1 over n, we're asking what number, in this case a, do we raise to n to get b, and so oftentimes b to the power of 1 over n is called the nth root of b. So now let's try a few examples with this in mind. And feel free to pause the video at any moment if you want to give them a go yourself. So here's what we're asking in this problem. Using the equivalence from the definition, we can rewrite this as some value to the power of 2 equals 25. So really all we're asking is what number did we square to get 25? And in this case, we should know that we square 5 to get 25. Therefore, 25 to the power of a half equals 5. Now for the second one, it's the same idea. We're asking what number did we raise to the 5th power to get 32? This one might not seem as straightforward as the others, but if you can recall, 2 to the power of 5 is 32. And so we get 32 to the power of 1 over 5 equals 2. Same idea for the third one, just so we get the hang of things. We're asking what did we raise to the 4th power to get 81? And that's going to be 3, since 3 to the power of 4 equals 81. So to write it as an answer, it's 8 to the power of 1 over 4 equals 3. So for the last one, we need to be a little careful with the minus signs here. But other than that, it works the same as the previous parts. So we're asking what number did we raise to the 3rd power to get -8? Well, we know that -2 to the power of 3 is -8. And so therefore, -8 to the power of 1/3 is -2. So it's good to note that all the properties for integer exponents are also valid for rational exponents. So let's take a look at the more general rational exponent form. And there are in fact two different ways of dealing with them, as we'll see, both of which you use property 2, as you see on the right, which is that inside the brackets, if we have a to the power of n, and outside the brackets, we have a power of m, then we get a to the power of n times m. So first, to deal with the general rational exponent, we'll rewrite this as follows. b to the power of 1 over n times m. And very clearly we are thinking about it as the product of two numbers. Now we'll use the exponent property, however we will be using it in the opposite direction that we did previously, with two ways of doing so. So we can have a rational exponent, b to the power of m over n, which would then equal b to the power of 1 over n to the power of m, or b to the power of m to the power of 1 over n. Now using either form, let's try to evaluate some more complicated expressions, and of course feel free to pause the video if needed. Let's use both forms here since neither one is too bad in this case. So let's take a look at the first form, where we'll have 8 to the power of 2 over 3, which is equal to 8 to the power of 1 over 3 to the power of 2, which equals 2 to the power of 2, which equals 4. So remember, to find 8 to the power of 1 over 3, we just have to recall what number to the 3rd power makes 8, and that would be 2, of course. Now let's take a look at evaluating the same expression with the second form. So again, we'll rewrite it 8 to the power of 2 over 3 equals 8 to the power of 2 all to the power of 1 over 3. So we have 64 to the power of 1 over 3. And now again, we're looking for a number that when cubed makes 64. And it may be a bit tricky to find, but we should know that 4 cubed makes 64, so the answer is 4. Notice, however, that when we use the second form, we ended up having to take the 3rd root of a much larger number, which can cause problems on occasion. Again, let's try to use both forms to compute this one, just to demonstrate the point that the second form tends to cause problems on occasion. So 625 to the power of 3/4 is going to be equal to 600 25 to the power of 1 over 4, all to the power of 3, which equals 5 cubed, which equals 125. We'll rewrite the expression 625 to the power of 3 over 4, which equals 625 to the power of 3, all to the power of 1 over 4, which equals, you won't need a calculator for this, but it's 244,140,625 to the power of 1 over 4, which again, you may need a calculator, is 125. As this part is shown, the second form can be quite difficult to use in computations. The root in this case was not an obvious root, not particularly easy to get if you didn't know it right off the top of your head. In this case, we'll only use the first form. However, we'll first use property 5 of our exponent properties to get the exponent onto the numerator and denominator. And for reference sake, a over b inside the parentheses all to the power of n is the same as a to the power of n over b to the power of n, provided b is a non-zero number. So we'll rewrite this as so, 243 to the power of 4 over 5 over 32 to the power of 4 over 5 is equal to 243 to the power of 1 over 5, all to the power of 4, using our first form, and same for the denominator, 32 to the power of 1 over 5 to the power of 4. So that becomes 3 to the power of 4 over 2 to the power of 4, which equals 81 over 16. Now before we end the video, let's try to tackle some simplification questions as well. So now we're going to tackle these one by one, and I'm only going to give you two, but feel free to pause the video if needed for both. Now for our first question, what we're going to start with is combining the powers in the numerator like we did in the previous video. And so that's using the law that x to the power of a multiplied by x to the power of b is the same as x to the power of a plus b. And so x to the power of 7 over 3 times x to the power of negative 2 over 3 becomes x to the power of 7 over 3 plus negative 2 over 3, which equals x to the power of 5 over 3. So now already we're left with a pretty simple fraction, which is just x to the power of 5 over 3 over x to the power of negative 4 over 3. Now using the property where if we have a quotient of the same base with exponents a and b, we can rewrite this as x to the power of a minus b. And so this becomes x to the power of 5 over 3 minus negative 4 over 3, which equals x to the power of 9 over 3, which equals x cubed. Now for our final question, we have inside the brackets m to the power of 5 over 4 all over m to the power of negative 3 over 4 all to the power of negative 1/2. So let's first simplify the inside of the brackets. So that's going to be m to the power of 5 over 4 minus negative 3 over 4, which equals m to the power of 8 over 4, which is just m squared. So now it should look pretty clean. We just have m squared to the power of negative 1/2. And so using our power of a power law, this becomes m squared times negative 1/2, which is just m to the power of negative 1. And because this is a negative integer exponent, we want to rewrite this as 1 over m. To end off this video, I'll warn you guys with the common mistake that students make in regard to negative and rational exponents, where provided b is a non-zero number, b to the power of negative n would equal 1 over b to the power of n, not b to the power of 1 over n. Now onto radicals.